Let's take a look at a topic that's probably familiar to many of you, namely the area between two curves. Let's say we're given two functions, f and g, and I'm just going to sketch a picture. Y equals f of x, y equals g of x, and I want two given x values, which I will call x equals a and x equals b. And what I'm after is the area enclosed between these two curves and between the x values a and b. Now, I don't think it's too surprising at this point that the area a is the integral from a to b of the top curve minus the bottom curve. This tends to emphasize the process of integration as an accumulation process, and by that I mean that if we pick a particular value of x, which I will call x naught, somewhere between a and b, and we look at the quantity f of x naught minus g of x naught, that's nothing more than that vertical length. And you can imagine a little bar as x progresses from a to b, moving from left to right, giving you the height between the two curves. And if you accumulate that height as we move from left to right, we end up with area. Later in this chapter, we will accumulate other values. If we accumulate area from left to right, one ends up with volume. So let's take a look at a particular example. Find the area between, or enclosed, between the curves y equals x squared and y equals, let's say, x plus 2. Let's draw ourselves a little picture here. Y equals x squared, of course, is a parabola. And y equals x plus 2 crosses the y-axis at 2. It's a straight line with slope 1. And we're after this area in here. So in our picture, the top of the region is bounded by the curve y equals x plus 2, so that will be our f of x. And the bottom of the region is bounded by y equals x squared. That will be our g of x. So it's still for us to find these two x values where the two curves cross, and of course we can do that by just setting their y values equal to each other. So we will set x squared equal to x plus 2, x equals x minus 2 is equal to 0, and oops, that should be x squared, and that of course factors x minus 2, x plus 1 equals 0, so x equals 2 or negative 1. That must be negative 1. That must be 2. Now we can finish this problem off quite easily. We will integrate from negative 1 to 2, the top curve, and again on the top is y equals x plus 2, so that's x plus 2 minus the bottom curve, so minus x squared dx. We can just clear those parentheses out. So minus x squared plus x plus 2. Very simple antiderivative. So we have minus 1/3 x cubed plus 1/2 x squared plus 2x, as x goes from negative 1 to 2. So negative 1/3 times 2 cubed plus 1/2 times 2 squared plus 2 times 2 minus, now we will subtract off the bottom value, negative 1/3 times negative 1 cubed plus 1/2 times negative 1 squared plus 2 times negative 1. After that, it's just arithmetic. So we have negative 8/3 plus 2 plus 4, so I guess we can write plus 6, minus we have looks like positive 1/3, and we have positive 1/2, and we have negative 2. And at this point, I think we can just finish that up fairly easily, just a matter of putting it over a common denominator, and that's the end of the problem.